Welcome to the lecture on writing chemical formulas of ionic compounds. I'm going to teach you the crisscross method, also known as the drop and swap. Everything in group 1 is going to be plus 1 in these examples, and everything in group 2 is going to be plus 2. You should note, though, that hydrogen can be minus 1 under certain circumstances when it's with the metal. Plus 1, and these are going to be plus 2. Before you do this lesson, you have to know that these elements, when they're in ionic form, are going to be plus 1, plus 2. This is going to be aluminum is plus 3. And don't worry about anything else right now for this lesson. Then you got minus 3 for group 15. Group 15 minus 3. Group 16 minus 2. And these elements right here specifically. And these elements in group 17 minus 1. And remember, these are the famous common ions. So just keep that in mind. Aluminum, you should know by heart, is plus 3. And you should know by heart that plus 1 is group 1, plus 2 is group 2. And then you should know your polyatomics. Your polyatomics, NH4 is ammonium, it's plus 1. And there are lots of polyatomics, but just for right now, these are the charges. You should know nitrate is famous, it's minus 1. Hydroxide is famous, it's minus 1. Carbonate is famous, it's minus 2. Sulfate is very common, it's minus 2. Phosphate is minus 3. So plus 1, plus 2, skip the transition metals and for this lesson, and then go all the way to plus 3, which is in group 13, and then you have minus 3, minus 2, and minus 1. Remember this concept. Everything has to add up to 0. So if I have 1 sodium and I have an oxide, I have Na plus and then I have O minus 2. But minus 2 and plus 1, that doesn't add up to 0. Plus 2 and minus 2 would add up to 0, but not minus 2 and plus 1. So if you think very hard, what could I do to make it add up to 0? Well, what I could do, I can add another Na plus. That would give me plus 2, because each of them are plus 1. And then that'll add up to 0. Okay? Now, I'm going to give you a shortcut way of doing that. Na2O. That's what that would mean. And I'm going to give you the steps to a shortcut of how to do that for all of the examples. Step 1, write the symbols of each element. Step 2, write the charges on top of those element symbols. Step 3, drop the symbols. Again, rewrite them, just drop them. And step 4, use the numbers and swap them and use them as subscripts without the charges. Now, let's look at another example. Al plus 3. Cl minus 1. Shortcut, just drop and swap. Just take the numbers and switch the 3 and the 1. The 1 there, but it's understood. And then you put the 3 there and that's it. Just swap the 3 and the 1. Another example. Calcium plus 2. It's in group 2, remember? So it's plus 2. And then we have nitride, which is minus 3. It's in group 15. We just swap the 2 and the 3. We're going to drop and swap. Ca, the 3 goes there. The N, and the 2 goes there. So we got Ca3 and 2. Just switch the 2 and the 3. Switch the 2 numbers and make them subscripts. We also call this the crisscross method. So now we have barium. Another example. Barium plus 2, S minus 2. But mathematically, that's just 1 to 1. So we just write BaS. It's just 1 to 1. So we simplify it. BaS. That's it. Okay? BaS. Another example. We have Al plus 3 and minus 2. Aluminum oxide. 2 and the 3. Just switch it up. Al2O3. Just switch up the numbers. Next, K plus 1, P minus 3. We're just going to crisscross, switch it up. Switch up the 3 and the 1. Remember, 1 is understood, so you don't actually write it. Next, calcium fluoride. So we're going to switch up the 2 and the 1. CaF 2. Just drop and swap. Drop the letters and swap the numbers. But take away the signs and use the numbers as subscripts. Next, calcium. And this time we're going to use phosphide. Just 2 and 3 is just going to switch it up. Ca3P2. Okay? Next, aluminum. Bromide. Switch up the 3 and the 1. AlBr3. That's it. The 3 and the 1. We just switch it up. Next, this is called the crisscross method. Take the Li plus 1, Br minus 1. And when we crisscross 1 and 1, we just get 1 to 1. Boom. That's all we need to do. Next. Okay. Okay, so now we have K plus 1, SO4 minus 2. Boom, what is that? That's a polyatomic. But you treat it like a group. So SO4 is just one group. Ba plus 2, OH, oop, another polyatomic, minus 1. Treat it like it's just one thing. Ba, okay, now we got 2 OH minuses, because we remember the idea of balancing it out. So we got 2 OH minuses. Boom. 2 of them. Just switch it. 2 and 1. 2 and 1. Okay. Remember, treat polyatomics as if it's one unit. Okay. Now, another one. What if we had aluminum and then we had a nitrate? Now, that NO3 might confuse people, but just pretend like NO3 will never change. It's just a minus 1 charge, a group with a minus 1 charge. So you just flip the 1 and the 3. You just swap the 1 and the 3. The NO3 will have that 3 that aluminum had. And then the aluminum will have 1, but we don't write 1. It's understood. We just put the NO3 in parentheses, take it 3 times, and that's it. 1 and 3 get switched. 1 and 3. 3 and 1. 1 and 3. Next, what if we had aluminum with the sulfate? Sulfate is one group. SO4, you can't change it. It's going to be a minus 2 charge. But we drop the SO4, we put the 2 there, and then we put the 3 there. There are 3 SO4s. We just swap the 2 and the 3. You just swap it. Remember, treat SO4 like it's one group and it never changes. You cannot change SO4. When you make the formula. Next, Mg is plus 2, not plus 1. Then we have ClO3, which is minus 1. We are just going to treat ClO3 like it's just one unit. It's one polyatomic. It's just one unit. So we're going to put it in parentheses, so it's just one unit. Put a 2 there as a subscript, because we're switching up that 2. 2, 2, see that 2 and that 2, they go together. Just swap it. Okay. Next, Mg is a plus 2 and SO4 is minus 2. But check it, SO4 is one unit with a minus 2 charge. It's just 1 to 1. 2 and 2 is just 1 to 1. So we don't need parentheses. We only need parentheses if there was more than 1. Very, very, very easy. 1 to 1. 1 to 1s are the easiest one. 2 to 2 is the same thing.